So let's go ahead and pick up with part 2 of this case study. And in this part, we're going to talk about how the Zippy quote repository and its associated other helper interfaces and implementations will be used in conjunction with the Jakarta Persistence API, or the JPA. Remember, once again, we're returning reactive types, but that's only via the service, which plays the role of an adapter to take the lists that are returned by the Zippy quote repository and convert them into fluxes. So the Zippy quote repository is a JPA-based repository that contains a database of quote objects. And we'll see here that there's a bunch of different pieces here. So Zippy quote repository is going to essentially extend the JPA repository, and that in turn is going to extend the list CRUD repository, which in turn is going to extend the CRUD repository. So there's all these methods that kind of come along for free here by using this means of integrating the Zippy quote repository that we write together with other stuff that comes out of the box. And then as you'll see, we define various methods here, one of which is going to be using Spring Data API keywords. So that's the find by quote containing ignore case method. And then the other one is one that we're going to write, find all by quote containing ignore case all in, which is the custom implementation of this stuff. So once again, we get a lot of stuff out of the box, which is nice. So anything that just does basic lookups by the various fields that are in the quote record or quote class comes along the ride. Here's what it looks like in Java format. So we have a class called ZippyQuoteRepository. That's a repository which says this can be created and modified in a declarative way by the JPA and Spring in order to provide all these other mechanisms out of the box. We extend JPA repository, which gives us all these CRUD operations. And then we parameterize the JPA repository with the type of class that will be in the database, which is this quote class. And then we say that the integer is the primary key, and that's the ID field here. This is the method that we put together using Spring's Data API, which will select all the rows in the database that contain the query parameter in a way that's case insensitive. Oh, by the way, make sure when you do your implementation of assignments 2C and ones come before that you properly lower case things to do case insensitive comparisons. Notice a few people had an issue with that. So here's an example. If we look up the word yow, we're going to get back a whole bunch of quote objects that contain that word yow in it somewhere. And this is the actual SQL query that corresponds to the Spring Data API keywords that are put into this method name. So we select anything from the quote table where lowercase quote is going to contain the query. The other thing we're going to do here is we're going to have the Zippy quote repository extend the multi-query repository, which, as we've seen before, is where we're going to put the custom methods that will do multi-queries you can't get out of the box using the JPA Data API keywords. So let's talk about that. So that's the piece down here, the multi-query repository. So we have an interface, and we'll see what this does in a second. It's going to do this. So that's the find all by quote containing ignore case all in with a list of string queries. And here's an example of what you could do. You could look for yow and yet, and that will find all the entries in the database that contain the keywords yow and yet in a case-insensitive way. And it's going to just find wherever they occur, it'll find basically substrings. And this is the actual SQL query, which mercifully we do not have to write. But unfortunately, we have to write the code to do this. So you could see whether or not you think it's easier to write the query than it is to write the code to do it programmatically. We'll look at that in a second. The reason we do this is we simply can't generate this using Spring's Data API. So under the hood, the way this works is using something called the repository implementation pattern. We've talked about this before. You can find out what that pattern is doing here at my ChatGPT shared session. And this is unfortunately difficult to divine through other means because it's not widely documented. You can look up repository implementation with Spring, and you get a little inkling of things, but it doesn't go into much detail. So the ChatGPT version is actually a lot more thorough. When we look at the implementation, you'll see that we use an entity manager, and that's basically the database session that performs the operations, the so-called CRUD operations in querying the SQL database to do various kinds of things. And then here's the code. We probably won't spend a whole lot of time on this because we've looked at this before, but the main thing is just to note that you can write the code programmatically, and if you're willing to put some time in with ChatGPT and other tools, you can make this pretty darn easy to understand by factoring out code that can be shared with different implementations that do either anding or oring together of the various parts of the predicate that we're searching on. All right, so that's the end of part 2 of this discussion.